This set of videos concentrates on calculating and using in other calculations the perimeter and area of different shapes. So first of all, let's define those things. The perimeter first. Perimeter is a continuous line forming the boundary of a closed shape. What does this actually mean? Let's consider a simple shape like a square or a rectangle. The red line round the outside there is the perimeter, and if we take that red line off and lay it out straight in a straight line and then measure the length of that straight line, that's the perimeter of the shape. So if you think about this maybe as a piece of string that you could wrap around a shape, the length of that piece of string is the perimeter of that shape. For some complex shapes you might actually have to use a piece of string to measure the perimeter. For most of the things we'll look at, there'll be a formula involved or a logical way to do it. So the next definition is that of area. The area of a shape is the space inside the boundary that the perimeter provides. So if we think about our square there, we can divide up that square into particular size units and then count those units to find out how many units of area are covered by that shape. In this example we can see that we have 1, 2, 3, 4 square units that cover the shape that we have, and those 4 units are all inside the boundary of the perimeter of the shape. So we can see that the area or the perimeter can often be found just by counting squares. Let's have a look at a couple of examples of this. Here's one shape, it's a rectangle. The perimeter is how far around the shape is. So we can see on one side there's 3 squares, then 4 squares, then another 3, then another 4. That gives us a total of 14 squares around the perimeter. So our perimeter is 14 squares. Now let's look at the area. Let's count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 squares inside the boundary, so our area of this shape is 12. We can also do this where whole squares aren't involved. This is a new shape. It doesn't cover whole squares, but we've got 5 units on one side, 5.5 on the next, we've approximated, 5 on the next, which gives us 5.5 on the other side. This gives us a total perimeter of 21 units. The area, well, we could count those 25 whole squares, but then we're left with 1, 2, 3, 4, 5 half squares. 5 half squares is 2.5. So our total area is 27.5 squares. For some irregular shapes, counting squares in this way is the quickest way of getting a good approximation to the area or the perimeter of the shape. But in most cases we will have a formula that allows us to work out the perimeter or area, and this is particularly true of all regular shapes. So let's have a look at those and see that, just remind ourselves of those formulae. You should know the one for the rectangle already. A rectangle has a base length and a height. If we call the base B and the height h, the area is B times h. That's very simple and straightforward. Let's have a quick look at an example. Have a rectangle with base 11 and height 8. Then our base is 11, our height is 8, area is 11 times 8, which is 88 centimeters squared. That was quite straightforward. Let's add a little bit more difficulty. Let's have a look at triangles. Triangles have a base and they have a perpendicular height. So how far from the base to the tip in a straight line. So the base is B, the height is h. The area for a triangle is a half times the base times the height. So here's an example. I have a base of 6 centimeters, the height of 7 centimeters, base 6, height 7, area is a half times 6 times 7. That's a half times 42, which is 21 centimeters squared. The really important point here is that that height isn't necessarily the length of one of the other sides. If your triangle is a right angle triangle, then the height will be one of the other sides. In all other triangles, it is not going to be the same. So you must make sure you're working with the perpendicular height, so the height from the base to the tip of the triangle, in a straight line, straight upwards. So if you're doing this measuring, you would have to use a protractor to make sure you were using a straight line upwards at 90 degrees. This idea of perpendicular height is used in some of the other formulae for other regular shapes, as we'll see with the parallelogram. Parallelogram has a base length from one corner to the other, and it has a perpendicular height like the triangle. So if we take the base and the height, the area is the base times the height. It's very easy to get confused with this one in the same way that you might look at a rectangle. Beware that you're using the perpendicular height here, not the length of one of the other sides. Let's have a look at an example to make sure that we've seen exactly what we're supposed to be doing. Here's a parallelogram. Our base is 12 centimeters, our height is 8 centimeters, so the area is 12 times 8, which is 96 centimeters squared. Okay, let's move on now to some more unusual shapes. Still regular shapes though. First of all, the trapezium. Trapezium looks a bit like a vaulting horse in a PE hall, I suppose. It has a base length and a top length, and it has a perpendicular height. So if our base is B and our top is T, then the area is a half of B plus T, so the average of those two lengths, times the perpendicular height. If we look at an example, we'll see clearly what we're doing here. Our example has a trapezium with a base of 8 centimeters. The top length is 4 centimeters, and the height, the perpendicular height, is 13 centimeters. So if we put those into our formula, we get a half of 8 plus 4 times 13. 8 plus 4 is 12. A half of 12 is 6. So 6 times 13 gives us 78 centimeters squared. For our final example, we're going to look at a shape you don't see very often, a kite, and we're going to also show how you get to the area, because it's an interesting use of logic to show you how to work out why the area is what it is. So a kite, we lay it on its side in this way, make sure that the straight line running through the center, through the long axis, is parallel to the base, and so that length is the base. And the height, as usual, is the perpendicular height from the base. So we call these B and H. And let's look here. If we take that triangle, move it up there, and the other larger triangle, and move it up to the top, we can see that what we end up with is a rectangular shape. But that rectangle is half of the height it was before. So our area is the base times the height, which is a rectangular area, but it's a half of the whole rectangle. If you go back to the triangle and the parallelogram and the trapezium, you can use similar techniques to prove the area formula that we've given for those shapes as well. An example. Here's a kite shape, has a base of 16 centimeters and a perpendicular height of 10 centimeters. And let's just look to see how those triangles change where they are and move to make a rectangle in exactly the same way as the other one did. So we have half of 16 times 10. 16 times 10 is 160. A half of that is 80 centimeters squared. So you will need to remember the formulae for each of these regular shapes for the area. The perimeter, you'll have to work out the perimeter by looking at the lengths that you're given, but the formulae for the area, you need to be able to recall them and use them the way that we have done with the examples here.